Hey guys, Jake here, coming at you with another math lesson today. Today we're going to continue discussing the Elite Guide to AP Calculus AB, my new book. If you want to get yourself a copy, scan that QR code up at the corner or go check out the link in the description or the pinned comment below. But we're going to continue talking about the foundations of differentiation. So in the last several videos, we've talked about how to find the derivatives of certain elementary functions. Well, today we're going to kind of take that a step further, and we're going to discuss some of the kind of a little bit more helpful, I guess, a little bit more, slightly more complex, but nothing too crazy, methods that you can use for finding derivatives of a little bit more complicated types of functions. So today we're going to be starting with the power rule. So before we jump into the problem, so this is the problem that we're going to use as an example to demonstrate the power rule. Before we jump into that though, I do just want to basically just show you kind of what the power rule is or what it says. It's essentially a formula. It basically allows us to find the derivative of some function that is generally in the form some variable base, whatever your variable is, typically x, t, something like that are going to be common, raised up to some constant power. Now, of course, you could have some sort of constant coefficient in front of this too. Obviously, that's what we're going to be dealing with in this example. I'll get into a little bit more detail about how to deal with that. But essentially what the power rule says is if we have some function like this, y equals a variable raised to a constant power, all you have to do is bring the power down in front of your variable and then subtract 1 from your power. So essentially you'll bring the c down in front, that'll become a constant coefficient. You'll keep your x base the same, and then you'll subtract 1 from your power. So your new power will just become whatever your old power was minus 1. So that's really all there is to it. That's essentially the power rule formula, basically the gist of what power rule says. So let's go ahead and do this example over here. If we have f of x equals 2x cubed plus 9x squared, and we want to find the derivative, we can do this using the power rule. So to find f prime of x, all we really have to do is look at each of these terms individually, right? Because if you have a function that is made up of two terms being added together, the derivative is just going to be the derivative of each term separately and then add them together. So the derivative of 2x cubed plus the derivative of 9x squared, okay? The other thing to keep in mind, whenever you have a constant being multiplied by something that you're taking the derivative of, a constant multiplied by some function of x or whatever your variable is, the derivative of this is the constant coefficient essentially just carries through, and your derivative is just that same constant times the derivative of whatever your function of x piece is. So to find this derivative, we essentially can just use the power rule like we showed over here to find the derivative of the x cubed part, and the 2 is just going to carry through as an additional coefficient in front there. So we're going to get 2 times the derivative of x cubed. Well, the derivative of x cubed, we'll use the power rule. So we'll bring our 3 down in front, keep our x base as x, and then subtract 1 from our power. So our power will be 3 minus 1, which is 2. Okay? Same idea for this other term over here. The 9 constant coefficient will just carry through. Then we can take our 2, bring it down in front as an additional coefficient here, keep our x base the same, and then our new power will just be the old power minus 1. 2 minus 1 is 1. So then we can simplify this. 2 times 3 would be 6. Keep our x as x, and then x squared is going to be that power there. And then 9 times 2 is 18. Times x to the 1, anything to the 1 is just itself, so it'll just be 18x essentially. So that's really all there is to it. That'll be your derivative, your f prime will be 6x squared plus 18x. So I hope you found this video helpful. If you did, be sure to hit that thumbs up button. Be sure to subscribe as well. We're going to continue going through the rest of the topics in the Elite Guide to AP Calculus AB, so be sure to check back for the next video. Thanks, I'll see you next time.